Okay. I'm going to tell you the title of this, and a lot of you are going to go, yes, I already have this thing totally down. I've got it figured out. I understand everything there is to know about vectors. And some of you might be like, well, I kind of can use some vectors, but I'm not sure I totally understand like how to do everything with them. And that's okay. If you're in my physics class, then we've done a fair amount of stuff with vectors, though some of that has just been sort of like, okay, here's vectors, now use them. And just sort of like up and running, sort of like a working knowledge. Part of the mathematics side of things is to sort of kind of delve a little bit deeper, to kind of give you a little bit of the background, kind of help you to, you know, fully work out all of the different scenarios so you can maybe see why this formula works, or why you want to break it down to this way or something like that. So we'll probably be going a little bit slower than we did in the physics, because in physics I'm like, here's vectors, now start using them with force diagrams and things like that. So if you've never seen vectors, that's great, because I'm going to assume that you don't know anything about vectors, and you'll have a really good foundation. So today we're going to focus on vectors graphically, okay, or geometrically. And at the same time, I'm doing sort of a trial run here with y'all, because last chapter's quiz grade was so amazing. I think I had the highest quiz grades ever, okay? I feel like a lot of that was because y'all had some really good homework to work on, all that online homework. What I'm planning on doing for this unit is I'm not going to assign any paper homework at all. All of the homework will be online, okay? Now, what that means is you're like, oh, I don't have time to work every single night on online homework. I said, okay, that's great. Right now I have 2 or 3 assignments due on Friday, okay? And I'm going to be talking about those assignments, doing some practice problems in class, Monday, Tuesday, Wednesday, Thursday, and you'll be able to, you know, so after today's talk, you'll be able to do probably some of, or maybe even all of the first homework assignment, okay? Then after tomorrow's lesson, you'll be able to wrap up anything you didn't, plus you'll be able to work on some of the next homework assignment. And you might be like, superstar, want to work on through as many of them as you possibly can and get ahead and then ask questions in class. That's great too. I love that. Okay? So, no matter what, after I finish talking, if I finish talking today about everything that's on the first assignment, you'll have at least 2 or 3 days to take care of that online homework assignment. And we'll give it a trial run. We'll see how it goes. The nice thing is it'll save us a little bit of time with paperwork, or it'll save us a little bit of time grading in class, unless I spend forever talking like this. So let's get to vectors. Okay, so what is a vector? Well, a vector is a directed line segment. So we're going to start way back at the beginning here. So this is a vector. Line segment, I've got a beginning and an end, and I'm going to put a little arrow on one of those ends to show a direction. Here's another vector. Here's another vector. Okay? Things that are not vectors would be things with an arrow on the other end, or something that curves. Vectors are always straight, they always point in one direction. Okay? A vector is a construct that has 2 pieces of information. Reread that info. Does anybody know what those 2 pieces of information are?
Speed and direction.
Close. Magnitude and direction. Magnitude is a fancy math word for size. Magnitude and direction. For example, this is an actual vector here. Parentheses, 5 miles, 20 degrees north of east. That's a vector. 5 miles, so that's 5 miles right there. Scale. 20 degrees north of east. So if that's east, we are 20 degrees north of it. So there you go. A line segment that is directed means it has a direction. So a directed line segment with a magnitude, which means a size, and a direction. Okay. Now a vector, which is 2 pieces of information, is in contrast to the other thing, which only has 1 piece of information. Does anybody know what something that has 1 piece of information is called? It starts with an S. A scalar. So you got a vector, which is 2 pieces of information, and a scalar, which is just 1 piece of information. For instance, 5 miles. X equals 5 miles. D equals 5 miles. S equals 5 miles, or whatever. Okay? See, I told you all. Just think, isn't this so much nicer? Just nice. Those of you that have seen vectors before, sort of like a going down a familiar walking trails. Everything looks familiar. All right. So some of you might be asking. Some of you from Missouri. Missouri is the show me state. Like, come on, show me. Why? Why vectors? Why do I even have to learn about vectors? This sounds like an airplane thing or some sort of crazy engineering thing. Why do I need to know about vectors? And the answer is because life is vectors. Physics too. But life is vectors. Jesus, head up please. Thank you. Let me give you some examples of quantities that are vectors and maybe also some quantities that are scalars. Now I've always said that pre-calculus, the whole point of pre-calculus is so that you can understand physics. So I'm going to give you some physics examples. All right? A scalar might be distance. How far were you? Oh, about 5 miles. A vector, displacement. Oh, well, I was 5 miles north of town. Oh, so you give me the magnitude and the direction. If you just told me 5 miles, that doesn't tell me which way you're going on Old Betsy. 5 miles that way, 5 miles that way. You said 5 miles. Okay? Vectors are great. Vectors are for those of you that are communicators. Speed. Well, sir, got you going 65 miles per hour in a 35 mile an hour school zone. All right? Well, that's just 1 piece of information, 65 miles per hour. A vector, velocity, has magnitude and direction. Got you going 65 miles an hour north on I-35. Well, that's not actually speeding, so 165 miles an hour going north on I-35. So you would have the magnitude and the direction. Later on this week, maybe beginning of next week, we'll talk about something called forces, which is just a push or a pull. Okay? Forces are vectors because if you push or pull something, you're giving it an amount of force, and you're giving it that force, a push or a pull, in a certain direction. Okay, so it's a vector. Something called momentum, which is sort of a concept which describes how fast something is going, but also kind of how much it weighs, how much mass it is. Okay. For instance, if, well, not me, but let's say Jesus were to punch Matthew there, okay, all right, Matthew might go, kind of flying back, a little bit out of his chair or something like that, okay, all right, but that's because he's hitting with a certain more amount of velocity with his hand or whatever, okay. Let's go ahead and hit his, let's not hit his head here because of what I'm going to give an example here, okay. If there was maybe something very, very small, say maybe like a bullet, okay, that was traveling extremely fast, it could have the same effect. It could, a very small bullet traveling very fast would also kind of could throw Matthew's body. You say, what's the, that's something called momentum. And we'll talk about that in my physics class here and there. Some other scalars, energy is a scalar, it's just a number. Power is a scalar, it's just a number. But vectors always have two pieces of information. So, I've talked about geometrically, let's show some geometry. Well, that's not so good.
What's the difference between energy and power?
Ooh, good question. Say it again, Josue? Did you say over time?
No.
Oh, if you said over time, that's correct. Power is how much energy is being delivered over time.
Oh, okay.
So, I mean, you could have like 5 joules, but you could have like 5 joules really fast, or you could have like 5 joules like pass like kind of slowly. You know what I mean? The difference is the power.
Okay.
All right, so there's a vector. Oh, we talk about vectors using this, I guess the most technical way is a letter with an arrow over top of it, but of course we get, and by we I mean I, get really lazy, so I just kind of draw that with a little, with only one of the arrowheads above it. All right, but that is not unusual, so just be aware of that. The length of the line segment tells you the magnitude. The direction of the line segment tells you the direction. I don't know any other way to say that. The direction is just the direction. Okay, so the magnitude is shown by the length. The direction is shown by the arrow. Okay, and I've got vector v. I'm going to say this is our notation. We could say vector A is equal to, this is our go-to example today, 5 miles at 20 degrees north of east. We use parentheses, ordered pair notation. Mathematically, this is what's called vector notation. Right here, that first number is the magnitude, and obviously the second number is the direction. So we're talking about directions. We normally refer to it as an angle. It's normally an angle. Theta. It can be degrees, or it could be radians, or it could be some sort of combination of like degrees and the cardinal directions, like north, south, east, and west. Like I have right here. For those of you that are going to take trig next semester, I seem to recall students, they always talk about the bearing or whatever, and where it's always like on a 5-degree bearing, and a 5-degree bearing would be like if north is 0, and then you've got like 5 degrees there, something like that. So when you get into that class and it talks about an angle, you just need to talk to your teacher, your instructor, professor, whatever, about, okay, where, if it says 5 degrees, is that from north or is that from standard position east or whatever? So that's just something that you'll have to clarify. Okay. Sometimes we'll use negative degrees to represent a vector. We don't have to. Obviously, if you have a longer segment, then you would have a larger magnitude. For instance, there's A, vector A, here's vector B. So vector B is going to be 8 miles at 20 degrees north of east. So I'll say there's vector A. It's 5 miles, 20 degrees. Here's vector B. Still 20 degrees north of east, so it's still along that same line, but little bit longer. So you can see the, larger magnitude, longer line segment. I know I'm flying through this. Does anybody have any questions? Being facetious here. Does anybody have any questions on this? So those of you that have never seen vectors, how are you doing? Or have y'all seen vectors before, no matter what? You've seen vectors before in your other classes. Okay, great. Some new notation. Sometimes we want to just talk about the magnitude. All right. This is what we'll do. Let's say vector A, actually. So we put the absolute value symbols around it. Okay. And the absolute value means what's the absolute value, or what's the magnitude of that? Technically, is what those things are. So the magnitude of A would be 5 miles. So that means magnitude. So they're talking about the magnitude. Obviously, we're just going to have one piece of information. So the magnitude would just be the scalar, so it would just be 5 miles. The magnitude of vector B would be 8 miles. Okay? All right, let's talk about the scalar multiplication, or a scalar times a vector. So let's say I have a new vector, vector W, which is 7 times vector A. Okay? So what does scalar multiplication mean? Well, it just means multiply the magnitude only. The direction is the same. What more by that? Well, 7 vector A's. Okay, so there's vector A. What if we get 7 of them? 7 times those. So I guess graphically, there's vector A. If I'm going to have 7 of them, it would look like 1, 2, 3, 4, 5, 6, 7. There's 7 of them. And this whole thing altogether is vector W. So, what's the direction of vector W? Yeah, it's the same direction. 20 degrees north of east. What's the magnitude of vector W? 35, yeah. It's just this 5 times 7, so it's going to be 35 miles at 20 degrees north of east. Go and copy that down while I take attendance. Okay. What if I had vector y, which was equal to 0.5 times vector a? Before we draw it, let's see if we can figure out what would be the magnitude and the direction? Oh, by the way, that 35 there, that was just, that was 7 times 5. How am I going to figure out the magnitude here?
If A is 5, between.
That's a 0.5, but yes.
Oh, 0.5, okay.
Yeah. 0.5.
Do the same as before, just multiply.
Yep, just multiply. So 0.5 times 5, what's half of 5?
2.5.
2.5.
2.5.
So 2.5 miles. Direction?
No, east.
Yep. 20 degrees
No, 20
north
degrees east.
of east. So Y would look, so it's about half of that. There's just a small guy right there. Okay, so scalar multiple is super easy. You just multiply the magnitude. That's great. We love that. Any questions on scalar multiplication? Okay. But what if it's a negative? Well, negative vector A means same magnitude. Help me out, class.
Different directions.
How different? Opposite. What does opposite mean?
Different direction. The opposite direction.
Give me a numerical value.
Negative.
No, south.
If it's going north, it's going south. But what if it's going like kind of north?
Then it's going kind of south.
Oh, but there's two types of kind of
Northeast,
south. There's kind of
uh,
southwest and there's kind of southeast.
Well, you never specified which north.
Okay, I'm not telling you north. What's a mathematical way that I can say go in the complete opposite direction?
Negative.
Make it negative?
Minus 180.
Minus 180 or add 180. That's what I'm looking for. Looking for a note more. So, add or subtract 180 degrees. So let's say that vector z is equal to negative vector a. The magnitude is going to stay the same. It's still 5 miles. But if I do a little sketch over here, there's 20 degrees. If I add 180 to that, ooh, that don't look good. That still doesn't look very good. Hopefully y'all can draw something better than I can. Okay, there we go. So if we add 180 degrees, what's the new angle going to be?
200 degrees.
Yeah, we could just say 200 degrees, and everybody knows that if you're talking 200 degrees, then that means from here. Okay, so origin, all is the positive x-axis.
South.
But we could give a cardinal direction here. We could say 5 miles. Now, since that's 20 degrees, I know that this is also 20 degrees. You could say 20 degrees south of west. South of west. So that's another way that you could put it. The big idea is basically we always want that magnitude is always going to be a positive number. So you can add or subtract 180 degrees. What if, I guess maybe we'll add, what if I'm down here like in this quadrant? Like what if I'm all the way over here? I've got this vector, let's say it's 7 at, let's say that's 270 at 290 degrees. Which quadrant is the opposite going to end up in?
Second.
It's going to end up in the second quadrant. Okay, that's why I said sometimes you can add 180 degrees or you can subtract 180 degrees. If you added 180 degrees, what are we going to get? 290 plus 180 is 470. Okay, now this is the one thing I'll tell you about vectors. We normally do not use angles that are more than 360, okay? Because there really isn't any need to, okay? I mean, you could say 400 or 420 or 470 or something like that, but why would you, okay? When we were dealing with rotations, then that made a difference, okay? When you're dealing with rotations, there is a difference between, 10 degrees and 370 degrees. They're both coterminal angles, but if you're talking about rotations, there's a difference between something moving like this and something moving like this, okay? But with vectors, there's really no difference. You're going in this direction, okay? There's no spinning around or anything like that involved. You're going in that direction. So we normally would never say 370. We would say 10 degrees, okay? Because that's 360. Now in this case, we have 470. So the logical thing to do, you could either, add 180 degrees and subtract 360 to figure out what that reference angle or what that angle is, the coterminal, or you could just subtract 180, okay? So 290 minus 180 is 110 degrees, and that'll tell you where it is. So just as a little side note, theta is usually between 0 and 360. Sometimes it'll go negative, but we'll never see anything more than 360. If you're dealing with radians, it's normally between 0 and 2 pi. Sometimes it'll be negative, but if it's negative, that's just sometimes it's a faster way to talk about negative angles when they're in the fourth quadrant than to talk about, all the way around. Okay, so that's what a vector is, how a vector is different from a scalar, what are vectors used for, magnitude, direction, scalar multiplication, opposite vectors or negative numbers. There's one big idea that we're going to talk about at the end here, and that is vector addition. All right? What happens if we want to add two vectors together? And this is where it gets fun, because we get to use the protractors here in a minute. All right. So, vector addition. If you're going to add two vectors together, the process is very simple. So to add vectors A and B, step one, draw A. Step two, draw B on the end of A. And step three, connect the beginning of vector A to the end of vector B. For example, there's vector A, there's vector B. To add them together, follow the steps. Step one, draw vector A. Step two, draw vector B on the end of vector A. B, here is the end of A. Step three, connect the beginning of vector A to the end of vector B. Beginning of vector A to the end of vector B. And that is going to give you vector A plus vector B. This is called the tip to tail method. There's also a method called the parallelogram method where you make a parallelogram, but I feel like that just is like, why would you in the world would you draw extra lines? This works out like awesome. Okay? Here's vector C and vector D. As a table, see if you can combine vectors C and D. Answer? Answer? Go ahead and draw E and F up there as well. Alright, so for vector C and D, do you have something kind of look like this? C and D. Start off drawing C. Then what did you do?
Connect the tail of E.
Okay, so so from right here, I drew D, something kind of like that, and then with a different color, pick the beginning of C, the end of D, and that is C plus D. Any questions? Great. What about E and F? First, draw vector E. Then draw vector F. Uh-oh, it's going to go on top of E. Eh, who cares? That's going to happen. So F, going to backtrack some of the way, but not all of it. And then, make kind of fun here. So the beginning of E, the end of F, right there. That is vector E plus F. Here's a question. Is there a difference between E plus F and F plus E? Let's find out. Okay, so that's E plus F. What if I were to draw F first? So F looks like this. Actually, I might. I'll draw it over here. So F. And then from the end of F, I'm going to draw all of E. So right here. There's vector E. I'll put a DF right there. And then from the beginning of F to the end of E. Huh. Is there any difference between E plus F and F plus E?
Yes.
That's E plus F. It's about this long, and it's going to straight to the right. It's about this long, and it's going straight to the right. If there's any differences, then it's just because I'm not drawing things exactly 100% scale. But yeah, they actually are the same. Vector E plus vector F does equal vector F plus vector E. Let me go back and show you, this is where the diagram helps out. This is draw A, then connect B to the end of it, okay? Down here, this is draw B, then connect A to the end of it. You See that? And this would give you vector B plus vector A. Vectors, it does not matter the order in which you write them. Okay? So, now, let us have a little bit of fun. Vector A, what do I want you to do? Oh, we'll have to hold off on the fun, maybe until tomorrow. I need to tell you about vector subtraction. Come on in. Grab a sheet of paper. Vector subtraction. So vector A minus vector B. Well, it turns out it's almost the same as vector addition. Step 1, rewrite as vector A plus negative vector B, or the opposite of vector B. And we talked about if there's a negative out front, what did we say? If there's a negative of a vector? Opposite direction. Okay, so same magnitude, opposite direction. Step 2, continue as addition. So, let's say there's vector A, there's vector B, and I want A minus B. Well, I'm going to first think about, well, what is the opposite of B? It's going to be the same magnitude as regular B, but in the opposite direction. So there's that. Then I'm just going to solve the problem, continue as addition. So draw vector A. There's vector A. Add to it the opposite of B. So wherever A ends, just right here, I'm going to draw negative B. And then from the beginning of A to the end B. That is vector A minus vector B. Okay? Any questions? Alright, so what we're going to do at the beginning of class tomorrow is actually, I already passed the protractors out, but we'll pick those up here in a minute. We're actually going to measure the angles and combine them and and do all this stuff and then measure what the result is, and it's going to be really fun. And we'll have a little prize of some homework points for whoever gets the most accurate answer. It'll be really nice. Okay? And then we'll basically say that that process is very frustrating and annoying, and is there a better way? And the answer is yes. Okay? So, your homework, you already have. It's online. If you start working on homework and you solve like the first 3 or 4 problems, and then you're like, oh, I can't get any of these next couple problems, that's because I haven't taught it to you yet. I've assigned more stuff than you know how to solve. But there is the work example if you want to be superstar and learn how to do that before you teach it. Alright?
Are we going to do the homework in class? Have time to do them in class?
Maybe. I'm not going to promise that. Because, I mean, right now you just work